Okay, so we've got our weirdly concrete problem here from XKCD about taking a myopic random walk. We learned the technical term last time, and we're dropping marbles along. We want to count the number of marbles that fall along the longest line between 2 points on the random walk. And we did discover that it does not count close enough. The line does have to explicitly go through the center of the marble. So what I would like to do in this video is do a little bit of investigation, right? Because this is neat. This shows you what the problem is about, but it doesn't actually show you what Randall's asking here of how many marbles would be in the longest line after n by k steps. And it is giving you number of marbles in the longest line, but it hasn't necessarily shown that as a function of n by k steps. So what I would like to do would be loop over probably just one of these for right now. We'll start with a loop over, let's say marbles. Let's do that. So what I would like to do is make a graph of that average that comes out of stat main and graph that average versus k. So I would like to do, please, for, we're going to do the k. So let's take marbles in range. Let's see, they defaulted this to 50. Yeah, so let's go down just a little bit to 40 up to 100 in units of 1. So for marbles in range 40 to 100 in units of 1. So this is basically the length of the thing, right? This is effectively giving the length of it because the length is going to be n by k. And so we are scaling up the length that way. Let's see, for marbles in range of this, I want to run stat main, right? I'm looking to run stat main here, but I want to retrieve this information about mean here. So I'm going to have this return mean. So when it prints it, it's going to actually return that as a variable. And so I'm going to have this do, let's just call it mean equals stat main. I could have it return the standard deviation. Let's do that too. Return syncdev here. So we're going to call that mean in syncdev because I could take that standard deviation and make that the error bars on my graph here. Okay, let me make sure that will run enough times here. So let's go from 40 to, let's just make this 45 for right now. Let me make sure that loop isn't going to destroy anything. Okay, I am getting a different number. I'm getting a different mean each time. So that's good, good. Okay, so now what I want to do is put these means and standard deviations in a list, or in two different lists. Okay, so we're going to make, this is going to be means. Hang on, I want to use a term that makes a little bit more sense there. On average, how many marbles would be in the longest line? Okay, let's call this marbles. Are they using camel casing or they're tending to use underscores? I tend to prefer the underscores to camel casing, but that's just me. So marbles in line. We're going to make that a list, and then we're going to make make it mean marbles in line. And then we'll do the standard deviation of the marbles in line. And then let's just keep track of marbles. In marbles equals that. I know I could go ahead and make that a list and then do it here, but I'd rather just append it. So let's go with mean marbles in line here. So let's copy all of these. Copy, paste, tab. So what I want to do with this is dot append mean. Oops, dot append. There we go. All right, let's copy that part then. Copy, paste, syncdev, paste, and we are using capital marbles for this. All right, so that should at the end give me mean and marbles. Yes. Okay, 44 and, oh wait. Oh, excuse me. I didn't actually paste in the name of my list here. All right, let's go mean here and in underscore marbles. Never type, Brian. Always copy paste when you can. You know this by now. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That looks like my mean values. Okay, cool. So this is giving me what I want. So now what I can do is make the graph that answers Randall's question. I can do a plt.plot because we already have matplotlib brought in, right? Let's see. We've already got matplotlib.pyplot as plt. That's all I needed to know. plt.plot. We're going to do in marbles. Okay, now here's the thing. Randall's question was after n by k steps. So instead of in marbles, I'm going to call this in steps. In steps. In steps. And the reason that I want to do that is because I want to be able to now change the the n value. And so we're going to, instead of marbles here, we're going to put marbles times spacing because this is n by k, right? And so this is going to be average number of marbles along the line, and this is going to be standard deviation of that average up there. And then this is going to be the n by k. Okay, awesome, awesome. Okay, and the num samples, I'm going to want that to be a larger value because 10 is not going to be very significant. So I'm going to add a 0 on there. Let's do 100. I'm not claiming 100 is significant. I'm just saying I would like a bigger number. Please do not roast me in the comments about my lack of knowledge of statistical significance. This is a demonstration. I'm not telling you how to do it. I'm demonstrating how you could do it. So we'll do plt.plot in steps by the number of mean marbles in a line. All right. This is going to take a hot minute. Especially with the printing that it's going to do here. So let's have this thing, let's actually turn that off. So if you're in Linux, the term for this is verbose. We only want this if we're being verbose. So if verbose there, tab that in there. Verbose just means, yes, tell me everything you possibly can. Verbose equals false means I just want the stuff at the end here. And yeah, let's give that a try. Oh yeah, let's get this back up to say 100 here. Probably still going to take a hot minute, so we'll probably cut here. Oh, whoops, I misspelled. Steps is there. Okay, it's still printing. Oh, yeah. I want to get rid of this part. So let's do if verbose. There we go. All right, fixed a couple things there. You know what? I am going to have it, though, print marbles here just so I can watch it go by. Okay, here we've got the average number of marbles on the longest line. Here we've got the number of steps n by k. I don't really see any sort of trend. It just looks like noise on there. I should have gone ahead and added the error bars, but the good news is now that data is saved in there. I did find out how to do error bars. You do plt.errorbar, t.errorbar. And so let's just copy the stuff that we had here. Copy and paste. Now, do I have to call that x and y equal to something? I do not, but I do need y error. Okay, so we're going to have comma y error equals. Let's grab the name of the standard deviation here. So that's the error off of that average. And since I have all that saved, it doesn't have to run that calculation again. Okay, yeah. So those vertical blue bars, those are the standard deviation around each of these data points here. And so there is very little, that's all noise. Yeah, so the variation here along the average is just noise that's lost in the standard deviation here. It's all there's no significant differences between, I don't think, any of those So that's kind of cool. It looks like the average is right around 1, which is kind of cool. Hang on, let's get the average of the averages there. So print for me, please. What's that going to be? np.avg, np.average, numpy.average. Okay, np.average of the averages. Here, copy paste. Just over 1. Okay, so is it actually 1, or is it supposed to be a little bit over 1? And if so, what's the significance of that number there? I mean, there's too much noise there in the data to be able to tell. So we'd have to run more trials for each one to hopefully get that standard deviation to go down. But goodness, that is interesting. That is an interesting unsolved math problem. All right, I'm going to be scratching my head over this for a little while. Thank you so much for watching. We will see you next time. Bye-bye.